Hey guys. All right. So next topic in our unit in inequalities called one variable quadratic inequalities. Okay. So guys, we use this technique quite a bit in math in the future. Okay, so we need to kind of know based on this function, where is it positive, where is it negative. Okay, in calculus down the road, you're going to be using this stuff quite a bit. You'll review it in calculus as well, but we're going to introduce this topic to you guys in Math 20 right now. So first example, so this is a one variable inequality. Now it's one variable because there's only one variable in here. There's only an x, there's no y. So that means our solution should only have an x in it. So what we're going to do is I'm going to add 15 to both sides. And we get this. And then I'm going to divide both sides by -3. Now the thing we need to remember is anytime we divide or multiply both sides of an inequality by a negative, like we're doing here, we're dividing both sides by -3, we need to flip the sign. So this is x is less than 15, now it becomes x is greater, and 15 divided by -3 is -5. The way we're going to state the solution is if I have 0 here, 1, 2, 3, 4, 5, this is -5 here, I'm going to put an open circle here because I'm not including -5, but I want all the values that are bigger than it, like this. And I'm going to put an arrow like this. Okay, so when we graph it on a number line like this, okay, this is how we do it. And here's my solution. My written solution is x greater than -5. And here's my solution on a number line. Okay, so x squared is greater than 9. So this is actually what we call so the first one was called a linear one, but this is now going to be at a quadratic inequality, okay, in one variable. There's only x here. So I say it's very tempting to just go and square root both sides. And if I did that, I'll get this. Now this is, I'm going to say partially correct, okay, but not fully correct, okay? So if I go x is greater than equal to 3, that's a solution. So if I say like 4 is greater than or equal to 3, 4 squared is 16, and 16 is indeed greater than or equal to 9. So anything bigger than 3 does work. But also, if I say I take a value smaller than -3, say I take -5, -5 squared is positive 25, which is in fact bigger than 9 as well. So the other part is or x is less than or equal to -3 as well. The way this would look on a number line, so here we have 0, 1, 2, 3, -1, -2, -3. So here's a 3 here and a -3 here. I'm going to fill in this circle and shade in like this. And I'm going to fill in this circle and shade in like this. So this is how I'd kind of state the solution on a number line like this. Now, example 3, I'm going to do the same question, but I'm going to show you a different technique. And we're going to use this technique in the future examples because it makes more difficult problems doable for us. So what I'm going to do first is set one side equal to 0. So I'm just going to subtract 9 and do this. Step 2 is I'm going to factor this part and determine what the zeros are going to be for this inequality. So if I factor this one, it would be x plus 3, x minus 3 is greater than or equal to 0. So the zeros are 3 and -3. So if I put those guys on a number line, we have -3 and +3. Okay, so it doesn't really matter about the rest of them here. But what I've done I've taken this number line and I've subdivided it into 3 parts. Here's a part, here's a section, here's the middle section, and here's this section over here. What we need to do is we need to test each section and see if it's positive or negative. So when I say test, I'm going to say test. I'm going to pick a number that's in this region over here. So say test -4. Okay, so if I look at this one over here, -4 plus 3 is a negative number. -4 minus 3 is a negative. A negative times a negative gives me a positive solution over here. So that means if I want the ones which are greater than or equal to 0, like I have here, that means greater than or equal to 0 means positive, which I have over here. So that means I am including this as part of my solution like that. Let's test -1. That's in between -3 and +3, -1 is, okay? -1 plus 3 is a positive number. -1 minus 3 is a negative. A positive times a negative is a negative number. So we want positive solutions. I have a negative one, so that means we're not including this region over here. I'm going to say test 8. Okay, 8 is a number that's bigger than 3. 8 plus 3 is 11, which is positive. 8 minus 3 is 5, which is also positive. A positive times a positive is positive. Okay, so my second region, I have another positive region over here. So I'm going to go and highlight this region over here. Okay. Now again, the way I state the solution over here is x is less than or equal to negative 3, or x is greater than or equal to positive 3. Now the word or here is important. I think some people will put the word and. It's these solutions and these ones over here. But actually, it's impossible for a number to be less than negative 3 and bigger than 3. So less than negative 3 would be a negative 5. But negative 5 is not bigger than 3. So the word or is important here. Okay, that's kind of where, in terms of logic, this word is going to be an important operator here. Okay, example 4, x squared minus 5x minus 14 is less than 0. We're going to do the second method we just learned in example 3. Step 1 is to factor. And this gets x minus 7, x plus 2 is less than 0. Okay, so what this less than 0 means is we are looking for negative regions. I'm going to put an arrow here. We want negative regions. Okay, so number line, our zeros are negative 2 and positive 7. Negative 2 and positive 7. Now, I'm going to put open circles here because we are not including. It's less than, but it's not equal to. Okay, so that means open circles here mean we're not including the boundary points. Okay, so let's test negative 6. Negative 6 minus 7 is a negative number. Negative 6 plus 2 is negative. Negative times a negative is positive. Let's test something in here. Okay, so let's test 0 is in between negative 2 and 7. We get a negative number. 0 plus 2 is positive. A negative times a positive is negative. Now, we want negative regions, which we have here, so that means this is going to be part of our solution over here. Okay, let's say a number in this region. So let's say test 8. 8 minus 7 is positive. 8 plus 2 is positive. A positive times a positive is positive. So this is going to be our only solution in here, in between negative 2 and 7. Here's the way we write the solution. Negative 2, 7, and we want all the x's are in between them. Negative 2 is less than 7, so we'll put a less than sign like this. Okay, no equal to signs because we're not including the boundary points here. Okay, and so the thing that people mistake, so they kind of get these guys mixed up sometimes. These inequalities have to be pointing in the same direction. Negative 2 is less than x, and that x has to be less than 7, and that's how this is going to work for our solution here. All right, similar idea. Just going to go ahead and solve this one. So step 1 is we're going to factor. And I think this one works as a minus 5 and a minus 2. Okay, so check it. 5x squared minus 25x minus 2x minus 25 minus 2 is negative 27. Negative 2 times negative 5 is positive 10. Okay, the zeros we're going to be plugging here. This 0 is going to be 2/5. And this 0 is 5. Okay, now we're not including those zeros, so we're going to have an open circle like this. All right. Okay, so now let's test regions. Say test negative 1. 5 times negative 1 minus 2 is negative. Negative 1 minus 5 is negative. Negative times a negative is positive. Let's say test 4. 5 times 4 minus 2 is positive. 4 minus 5 is negative. Positive times a negative is negative here. Let's test 10. 5 times 10 minus 2 is positive. 10 minus 5 is positive. Positive times a positive is positive as well. We want the ones which are less than 0, which means negative. That means we want this region here. So our solution is 2/5 is less than x, which is less than 5. Okay, example 6 is a little bit different, but I mean, same process exactly. Step 1, we're going to set one side to 0. So I'm going to subtract these guys, bring them over here. So x squared minus 3x minus 28 is greater than or equal to 0. Factor x minus 7, x plus 4 greater than or equal to 0. Our zeros are -4 and 7. And now we're going to test. Take a number in here, say -6. -6 minus 7 is negative. Negative, we get positive in this region. We want positive solutions, and we're in this case we have an equal, so we're including the boundary point of -4, like this. Okay, let's test, say 0 in here. 0 minus 7 is negative. Positive, that means we're negative, so we do not want this one because it's a negative region. We want positive regions based off this. Say 8 is in this region. We have positive, positive, positive. So we have this region over here. So our solution is x is less than or equal to -4, or x is greater than or equal to 7.